Thank you very much once again. Good afternoon. You are all welcome. Now, you are welcome to the new semester. I am Dr. V. Olutayo, your facilitator for this particular course, CIT212. That's System Design and Analysis. So, once again, you are welcome. Now, to continue, let me share my material which I have for you. Today is the first day of the lecture, and then we are going to have the introductory part of the lecture. We look at some of the fundamentals, some of the basics of the course today. And from next week, we are going to start from our week 1 till we finish the course. So you are all welcome. Let me share my material which I would like to use today. Thank you. I believe you can all see the material as I'm talking now.
Yes, sir, we can see it, sir.
Very good. So, once again, you are welcome. You can all go to your portal. You will see all the materials there, and week by week, it has been broken down for easy reading and for easy understanding the course. And this course promises to be exciting. Like I said before, I'm the course facilitator for this particular course for this semester. So we will look at the introduction part of the course today, majorly. So from there, we'll move on. So the course is System Analysis and Design. That's the CIT212. And under the introduction, the course is a 3-credit unit course. It deals with the analysis, design, development, and development, implementation, and maintenance of computer-based information systems. So that's major thing we are going to be looking at. Like I said, it's actually deal with the analysis, design, development, implementation, and maintenance of computer-based information system. And some of the knowledge and some of the understanding you have had as regards computing. So we are going to leverage on that. So which will give you an opportunity to are familiar with basic computer hardware and software concepts, as well as some of the programming languages, the ones that you have done. Also, the programming experience acquired is complemented in the course with system experience. So this will enable you to cope with the number of components in a system, in the system development approach, and immerse you correctly to result in a successful project. So the material has been broken down for you, and week by week, topic by topic, unit by unit, for you to actually have the understanding. But every week we shall be looking at them as we go on in the lecture. So this course will gives you a brief overview of the course content. So what will you likely to learn in this particular course, this system analysis and design? Now, the main purpose of this course is to provide the necessary tools, analyzing and designing systems. It makes available the steps and tools that will enable you to make proper and accurate decisions about systems whenever the need arises. This we intend to achieve. So we have to look at some of the aims which we want to achieve as we run through this particular course. The very first one, the aim is to introduce the concept associated with the system development. introduce the concept of, introduce the concept associated with the system development. 2, provide necessary tools for analyzing, designing, developing, and implementing a system. Also expose the relationship between hardware and software when it comes to developing a system. Also highlight the roles played by various stakeholders in software development life cycle. Now, what are the objectives now? And the objectives we want to achieve from this course. So by the end of this course, we should be able to achieve the following objectives. 1, to describe the basic elements in system. Describe the basic element in system analysis and the role of system analyst. Also, describe different reasons for developing a new systems project. 3, describe the various system analysis and design tools. 4, select a project out of a number of project requests. Also, enumerate the role of quality assurance in various stages of a system development lifecycle. 6, explain the characteristics of good documentation and its various types and the tools needed for documentation. Also, 7, explain the various types and stages of system implementation and conversion, as well as system maintenance. So all these objectives that I've highlighted for you will be what we'll be looking at to actually achieve by the end of this course as we move on. So now, walking through this particular course, so what are those things that we are equally expecting? So in order to have a thorough understanding of this course, you will need to read and understand the content, the practice, the steps by designing a mini system for your department, and of course for yourself, and be committed to learning and implementing your knowledge. This course, of course, is designed to cover approximately certain number of weeks, and it will require you devote your time. You should also do some exercises as we move on. Now, as we move on, let's now try to look at some of the things we look at. Now, under the introduction, the basic summary of what we want to achieve, we are talking of the introduction. That's what we are talking of now. So we have to look at the course holistically and see what we want to achieve as we move on, before we now take it one after the other, topic by topic, week by week, as we move on. Now, the system analysis and design introduces you to basic techniques and skills you need to analyze a system, and then design, of course, develop, and implement. You can see it actually involves those 3 things as we move on in the course. Don't forget, it said system analysis and design actually involves design, develop, and also implement a new one to meet the needs of users. That is, those are the intended to be acquired. That is the knowledge intended to be acquired in this course. So the content of the course material was planned and written to ensure that you acquire the proper knowledge and skills for the appropriate situation. Now, real life situations have been created to enable you to identify and create some of your own. So the essence is to get you to acquire the necessary knowledge and competence. And by equipping you with the necessary tools, we hope to achieve that. So as we move on, I hope we will all get the basis of the course as we move on. Now, one of the topics which we have to start looking at is what we call system analysis. System analysis is one of the very first thing that we have to look at. I haven't given you the background under this part of the introduction. So we will look at some of the fundamentals under system analysis. Don't forget, the course is system analysis and design. Now we'll look at the system analysis first of all as part of our introduction, And from there, we first of all look at system. So now we are talking of system analysis and design. Then we have been talking of system analysis and design. The system in question, what do we mean by that system? That's part of what we are going to look at now as part of our introduction. So the system we are talking about, what do we mean by the system? System analysis and design. So the word system covers a very broad spectrum of concepts. This is derived from the Greek word systema, which actually means an organized relationship among the functioning units or components. Of course, when you talk of a system, a system, we call it a whole of things. That is a complete whole of things. That's a system which comprises of so many components. By the time we move on, you will see that we have different types of system, but we are talking of a system generally now, a whole of a thing, whereby some things are connected or are combined together to make a whole system. So a system actually comprises of so many components. So like I said, this particular word is from the Greek word systema, which means an organized relationship among functioning components. So in our daily life, we come into a contact with the transportation system. We are looking at type of system now that are actually available. We have what's called transportation system, the communication system, the accounting system, the production system, economic system, and so on. Now, of course, the computer system, of course, because computer too is a system. Now, similarly, we equally have what is called business system. We have what is called business system. Business system are the means by which businesses, organizations achieve their predetermined goals. A business system combines policies, personnel, equipment, computer facilities to coordinate the activities of businesses, organization. Essentially, a business system actually represents an organized way of achieving the predetermined objective of an organization. So, like I said, we are looking at different types of systems in our day-to-day activities. Like I said, you can begin to imagine what a system is, like we are talking now. So, we have looked at some of the types of systems, and we still have far more than that. Of course, we have, even in our body, that's what we call digestive system. Of course, under the digestive system, you have so many components that are actually joined together, and many other systems that we can actually talk about. Now, there are various definitions of the word system, but most of them seem to have a common idea that suggests that a system is an orderly grouping of interdependent components linked together according to a plan to achieve a specific goal. This is very important. We should try to put it in mind and take note of this particular definition. Like I said, we have been talking of a system. The course is system analysis and design, and we must understand this concept of a system very, very well. As don't forget, under this part of our introduction, part of which we will still look at in our next lecture, but I'm trying to lay the foundation, the background for you to understand the word, the system, general description of a system. The system is an orderly grouping of interdependent components linked together according to a plan to achieve a specific goal. That's a system. An orderly grouping of interdependent components linked together according to a plan to achieve a specific goal. It is only when those components are linked together, that's when you can now call it a system. Any type of system you are talking about, or anything that is called a system, it must be connection, grouping of components. By the time all those components are linked together, they will now achieve a common goal, a particular focus. Just you can have it could be in any form. That is what we call mechanical system, electrical system. By the time you have some components that are done together in order to achieve a particular goal. So that's the specific thing about the system. Now, the word component, what do we mean? Because we are talking of a component under a system now. The word component may refer to a physical part You can see engines, wheels of cars, managerial steps, planning, organizing, controlling, or a subsystem in a multi-level structure. The component may be simple as the case may be. It may also be complex. It may be basic. It may be advanced. You can see now we are talking of engines now. Here we are talking of car. You can see so many parts are combined together to make up a car. Of course, the purpose of a car is to convey you from one point to another. And before a car can move from a point to another, of course, so many things must have been joined together. You have the wheel, you have the tire, you have the engine, you have so many things. At the end of the day, you have a common purpose, which is to move and convey people point to another. It becomes a mechanical system. It becomes a car system. So this is exactly what we are saying here now. So in some situations, the system you are talking about, it may be a simple system, it may be a basic system, it will at the same time may be complex or advanced, depending on the environment in which we are trying to look at the kind of system we are talking about. We are looking at a system holistically now, not just computer system. And of course, computer system, as the case may be, so many things that have been put together in order to have a particular device, which you call a computer. Of course, you have so many things, both the software and the hardware joined together. You have some of the other components, all of the other things that are put together. You have the motherboard, you have the memory, you have the operating system. So many things before a computer can be say this is a computer that can be useful and to perform any type of function we have tried to ask the system to do for us. I believe you are with me. Can I move on?
Yes, you can. We are with you, sir.
Yes, sir. Yes, sir.
Okay, I can move on. Everybody is hearing me clearly. Yeah.
Yes, sir. We
Yes,
are.
we can hear
Yes,
you,
sir.
sir.
We are
We
with
can
you,
hear
sir.
you. Can move
It's
on, sir.
very good. So now the component may be simple, like I said, it may be basic, it may be complex. So now they may be a single component with a keyboard. We are talking of computer system now, like I said. There may be a single computer. There may be a single computer with a keyboard, memory, and printer, or series of intelligent terminals linked to a mainframe. So in either case, each component is part of the total system and has to do its own share of work for the system to achieve desired goal. So one thing you must understand when we are talking of a system, the system must perform a particular goal, a common goal, haven't put together so many things. And if you discover if a particular component is not working properly or is not there, note that such a system will not work. And that's one of the things about the system. So every component must work to achieve that common goal. It's just like the computer system we are talking about now. If you have a situation whereby you have your system and probably just as simple as keyboard that is not part of your system, how do you want to use it? How do you want to communicate with the computer? So you will now see that in that case, that particular system is not yet complete. So, and ditto every other system that you may actually be thinking about. Now, each component is part of the total system and has to do its own share. So every component must perform its own function. And if there is a particular component that is not working well, or the result of too much use, it can be faulty, that such type of component has to be detected and fixed on time in order to have a working or a workable system. Now, we have what is called system study, system analysis, and the system approach. Now, system study. What do you mean by system study? What do you mean by system analysis and system approach? Don't forget, everything we are still talking about, we are still under system, under the concept of system analysis and design. So we have to look at the word system in an holistic manner. Now, what do you mean by system study? Now, system study may be described as a study of the operations of a set of connected elements and of the interconnections between these elements. You can see now. You see interconnections between a study of operation of a set of connected elements. That's the key word there now. Study, system study. Set of connected elements and of the interconnection between these elements. So it shows clearly that one cannot ignore any part or element of a system without first finding out the effect the element has on the operation of the system as a whole. So we can understand this with the help of a system analysis. So you can now see now, like I was explaining to you, the other time, that when you have components within the system, each component must work properly and must work in a way that, yes, it must work in a way that, yes, they actually will not affect the whole system. The point is that any component that is not functioning the way it's supposed to function will affect the functionality of the whole system. That's the system study is talking about here now, because it is the system study that will lead to system analysis. Because if you don't study the system, then why will you now? What is now the basis for system analysis now? So that's exactly what we are saying here now. Just is the connection between system study and system analysis. So if it shows clearly that one cannot ignore, you cannot ignore any part or element or component without first of all finding out the effect that that particular component has on the system as a whole. So we can understand this with the help of a system analysis. So when you are now trying to look at the component and see a particular one that is not functioning properly, then we can try to find out through system analysis. Now, there is a difference between system approach and system analysis also. So that what led to system analysis is what I've just told you now. Then the system approach now also shows a set of procedure for solving a particular problem. That system approach now. It applies scientifically, it applies scientific methods to observe, clarify, identify, and solve a problem with special care being taken to understand the relatedness between elements and their system characteristics. So, however, system analysis is the management technique which helps us in designing a new system or improving an existing system. So you can now see the fundamentals of what we are trying to talk about in this particular concept now. So you can now see where system analysis now comes in now. So the system analysis is the management technique which helps us to in designing a new system or improving an existing system. So when you are trying to now approach the system, then you now know in the course of the system approach here, that is when you will now know what next, whether it's to improve the existing system or to design a new system. So, but under system study, you first of all look at the component. When you look at the component, now in the course of looking at the component is the system analysis that will help you to look at each of the components and now see that each of the components, they are now working well. Don't forget, we are looking at a common goal. We are looking at a common result, which will not actually affect the workability or the output of the whole system. So every stage, every nomenclature of this word, they have their own importance as far as system analysis and design is concerned. System study, system analysis, and system approach. So like you can see now, so it's the system analysis that will now help in designing, because that's the one that will now give out the general result. Oh, this system is no longer useful as far as this organization is concerned, or this system is still okay. What we'll do is to optimize it or to upgrade it or to repair it, whichever type of anything that thing actually requires. Is the system analysis that will do that. When you have carried out system study as well as system analysis and of course system approach, So these are some of the things you must be able to understand when the concept of the course, that is system analysis and design. Now, moving forward, what are the characteristics of a system? I haven't given you the general definition and description of what a system is. We have looked at the system analysis. We have looked at the different types of, we have looked at system type of different types of systems. We have highlighted some of them. Now let's see the common characteristics of a system. Don't forget, everything we are talking about, we are looking at the holistic system, not just computer system now, but we are looking at the system generally. So at this level, they have almost the same approach in any type of system you are talking about. And that's the first thing for us to really get to understand. Now, let's look at the characteristics of a system. Based on the definition of a system, it is observed that the following characteristics are present in all systems. Number one, organization, which is true. Number two, interaction. Next one, interdependence. Next one, integration. Next one, central objectives. Now, all these are very, very important as far as a system is concerned, because there is no system that will not have a very good organization. Very, very key. Those four points that we have highlighted, very, very important. Organization. Now, let's look at organization. Organization, all these 4 to 5 characteristics, they are general to every system, and ditto computer system as well. So there is no system that does not have all these characteristics, because a system actually wants to achieve a particular goal depending on the type of system you are actually referring to. Now, organization. Organization implies structure and order. It is the arrangement of components that helps to achieve objectives, which is correct. Now, in the design of a business, of a business system, for example, the hierarchical relationship starting with the president on top and leading downward to the blue collar workers, which represent the organization structure. Likewise, a computer system. Likewise, a computer system is designed around an input device, a central processing unit. You can now see, we are now narrowing it down to computer system now. A computer system is designed around an input device, of course, which, like I said before, a central processing unit, an output device, and one or more storage units. When these units are linked together, they work as a whole system for generating information. You can see now, this is almost the summary of what we have been talking about since. Because, when you have different components, small components that are scattered, they must be organized. There must be a good link between those components and where to actually place them in a way that they will have to have their normal functions. Because if they are not properly placed, that system will not achieve its goal. So that's why organization is very important as part of the characteristics of a system. So there must be a very good organization, that is the arrangement of the component, which will help to achieve that common objective. It's just like a car system. You see, when you have all those different parts, you have the engine, you have the gear engine, you have this, you have that, you have the tire, you have the brake, where the brake is supposed to be. All those things must be put together in order for the car to move and convey people from one point to another. So that is the organization. And the next characteristics, of course, is this, which is the interaction. Now, this is key as well. Interaction refers to the procedure in which each component functions with other components of the system. In an organization, for example, purchasing must interact with production, advertising with sales, and payroll with personnel. In a computer system also, the central processing unit must interact with other units to solve a problem Of course, we have other units apart from central processing unit. You have ALU, arithmetic and logic unit. We have memory unit. We have operating system unit. We have so many other units within the system. So they must interact together in order to solve a problem. Now, in turn, the main memory holds program and the data the arithmetic unit uses for computation. So the interrelationship between these components enables the computer to perform. So there's no way we can rule out interaction, which is very key as far as a system is concerned. When you have had a very good organization, by the time those things are organized properly, then there will be interaction. And of course, that's what will make the thing work. Just like any type of system. You have a computer system, you on it. By the time you press the button on, the signal to the panel of the system, your system comes up. From there, you have the system to open a particular document for you. From there, the operating system will signal, okay, this is, and so on. You see, the way and manner, all those things will continue to process, or any type of system at all. Just like the car system we are talking about. You on your car, after which you want to move, you put the gear into a particular level, because if you want to move and the gear system, I mean the gear component of a car, if you don't put it at the right place, the car will not move. That's still part of interaction. So why the gear component will not interact, then from there the engine too will send signal that is already working, then you have a very good interaction. Then the next thing is for you to move, and so on like that. So ditto any other system that you are actually trying to talk about. Also, interdependence, which is the third characteristics. Interdependence, as you have all those components, they still have their dependence and they have their interdependence. So interdependence means that components of the organization or computer system depends on one another. That's the meaning of interdependence. That is, they are not alone. They are not independent. If they are independent, then they cannot achieve anything because they are components. So a particular component needs another component to function. This particular component needs another component to function. For instance, you have about 5 components which makes a system work. So if there is a particular component that is not trying to interact with another one, of course, that means they are interdependence. So interdependence means that component of the organization or computer system depends on one another. So they are coordinated and linked together in a planned way to achieve an objective. Like I said, system has a particular objective, and that objective is as a result of collective responsibility of every component. And then we now have maybe the integration. Of course, the integration, they have to be integrated. Integration is concerned with how a system is tied together. It is much than sharing a physical part of location. It means that parts of the system work together within the system, even though each part performs a unique function. So successful integration will typically produce a better result as a whole, rather than if each component works independently. Like I told you, of course, there is no component that is independent, that is totally independent. They will have to be integrated together in order for them to work as a system so as to achieve a common goal. So if you have a successful integration, which will now produce a better result as a whole, rather than having a component that is working on their own independently, they cannot achieve anything until they are integrated together. Because one thing is for you to have a good organization, another thing is for you to have a bad integration, because you may have a structure, which is the organization. If the organization is not integrated and they don't really seem to get their working principle together in a proper manner, that is the integration now, in a way that it will allow them to have a maximum output, or a maximum output. Then If you don't have a very good integration within a very good structure, then you cannot achieve the maximum output. But when you are well integrated together, or when the components are well integrated, then you achieve your maximum output. Then the last but not the least, of course, which is the central objectives. The central objective. Now, what is the objective? Like I said, every system wants to achieve an objective. Yes. So what is the central objective now? So the central objective is which is the last characteristics of a system. So objectives may be real or stated, although a stated objective may be the real objective. It is quite common that organization may set one objective and operate to achieve another. The important point is that users must be aware of the central objective well in advance. So, like I said, a system will have a particular objective that they want to achieve. Ditto any organization that is having a system that is a particular a particular system that they want to dish out. So just like we are talking here now, if you are operating as an organization and that's a system, because in that organization, you have small units within the organization. Maybe you have depending on the type of organization anyway, the production unit, the sales unit, the customer care unit, and so on like that. You have all those small units which will be integrated together to achieve a common objective. So the central objective is that you must be able to ensure that probably in that organization is to have a good maximum relationship with
Hello, sir. We can't hear you. I can hear you.
He's out. Network just kicked him out now. Maybe he's going to log in again.
Yeah, my fellow students. Please, anyone in computer, mathematics and computer science. Hello. Hello.
Cannot hear you. Cannot hear you.
Please, anyone in computer science.
I think most of us are computer science students.
Mathematics and computer science together, the combination of both. Please help a brother out.
If there's anyone, please indicate.
Send my number to the chat section. Partner, please.
I have someone though.
Okay, please, if you do, just
which study center are you?
Forward me the number.
Hello, can you still hear? Hello, can you still hear me?
Yes, I can
hear you.
We
can hear you now. We can hear you now. We can hear you now. Sir.
Sorry, I had the network problem at this end here. Sorry. So
yes, we understand.
Okay, sir. We can hear you. Thank you, sir. It's like it's off again. The lecture is off again.
So I think we can go on now.
Yes, sir.
Yes, sir.
Okay, very good. So
Yes,
I
sir.
was trying to, okay, we were trying to explain the characteristics of a system. So I think we are through with that. So we want to briefly look at the elements of systems analysis now. So don't forget, we have been able to look at some of the characteristics of a system. Like I told you, depending on the type of system we are talking about. So now briefly, let's look at let's look at some of the elements of systems analysis. So there are some basic features of some of these things which we have to note very well too. So there are basic elements in system analysis. The first one is output, which is very key. You must understand this when we are talking of system analysis. Don't forget that under this introduction, under this lecture that I have told you, we look at the system study, we equally look at the system approach, then we now look at the system analysis. You can see how the three of them try to connect themselves in order to achieve a purpose, because it is only when you look at the small part, which is the system study, analysis of it will now give you what has happened to each of the study, which is the component. Then from there, when you are now trying to approach it. Now, the four basic elements which must be considered: the output, which is very important. The output is very key when you are doing system analysis, because if you are trying to carry out an analysis of a system, what is the purpose? What do you want to achieve? What is going to be the end point? First of all, we must determine what the objective or goals are under system analysis. What do we intend to achieve? What is the purpose of our work? In other words, what is the main aim behind the system? Defining aim is very vital in system work. If we do not know where we want to go, we will not know where we have reached, which is very important. So at every point in time that we want to carry out system analysis, we must know where we are going so that we know where we are. So we shall be unnecessarily be wasting time and energy in the process. Once we know our aim, then we can try to achieve it in the best possible way. The user department has to define this objective in terms of their needs. So this becomes the output, which is the system analysis keeps in mind. So when you are trying to carry out an analysis, there must be an objective, there must be an output, there must be end result, which must be, first of all, be highlighted before the analysis actually starts, before you start doing the analysis. Of course, we have also, the same way we have output, we have the input. That's another key element that is important as far as system analysis is concerned. So once we know the output, of course, we can easily determine what the input should be. Sometimes it may happen that the required information may not be readily available in the proper form. So this may be because the existing form are not properly designed. Sometimes it may not be possible to get the required information without the help of top management. So if the information is vital to the system, then we should make all possible effort to make it available. Sometimes it might be too costly to get the desired information, but it will be rather better in such cases to prepare a cost-benefit analysis to convince the management that the necessity for acquiring the information. These essential elements of input are probably accuracy, timeliness, proper format, economy, files, and so on. So all these are input. That is when you have already highlighted all your so-called output, that is the end result of which you want to achieve. Then, of course, you can begin to look at what will now be in form of the input that will make you achieve that particular outcome. Also, the processes, no. The third one is the files. The files. So as the one implies, files are used to store data. Most of the input necessary for the system may be sorry. So as the word implies, So files are used to store data. Most of the inputs necessary for the system may be historical data, or it may be possible that these are generated from within the system. So these are stored in files either in terms of isolated files or in large volumes. So we are talking of the characteristics now, don't forget, elements of system analysis. So when you are carrying out analysis, output first, input second, files, whereby all those ones that you have been able to identify will be kept, because we are talking of a very large situation. We are talking of a very large analysis. For instance, if you are to carry out system analysis on a very big company that is having nothing less than probably 500,000 or 800,000 staffs, and they have locations in various parts of the country or in various parts of the, so it depends on the type of analysis you are trying to carry out. So it's not a small thing. So you have to have a very separate files that would be kept aside for all those things in the course of your analysis. Also processes. What do we mean by this? Now, here we come to the details of how the inputs and files are converted into output. So this involves the programs and the way in which data is processed through the computer. The processing involves a set of logical steps. These steps are required to be instructed to the computer, and this is done by a series of instructions called program. So you can now see that what we are talking about system, elements of system analysis. And this system analysis we are talking about, like I said, involves already you have an existing system. You want to carry out analysis on those existing systems. Probably, maybe like I said, you are looking at the reason why you want to carry out the analysis, which will actually form your output, your result. Okay, probably this system, they have been in existence for long and they are not giving the required performance. Maybe the performance of some of this system of the system is very low, or they are low, as the case may be. Looking at your performance measures and performance activity, probably in terms of output, in terms of production, in terms of whatever you have been able to get before. So you can now see a decline in whatever you are doing. So you now discover that there's a need to carry out analysis on some of these systems, on some of these machines that are being used to get our product, to produce our this thing and some other things like that. So in the course of that, in course of doing that, you will have some highlight. Probably one, maybe there's need for you to get a new set of systems, or there's need for you to update these systems, or there is need for you to improve some of these systems. Maybe some components are no longer good, you have to remove them. That is form of upgrade. Probably you upgrade some of those systems, not necessarily mean discarding them or changing them or going for a new set of systems. So there must be a need for you to first of all have a reason why this analysis is supposed to be carried out, or people are complaining. Maybe you are into production of some things. You can even be a designer of some of these computing devices. Probably you are the one designing a set of software, maybe, or operating system, Android or IoT, that is the one they are using for iPhone, or the kind of operating system they are using in most of these systems. And at the end of the day, you discover that customers or users are complaining about a particular section. Oh, then you carry out an analysis. So when the analysis is being carried out, then you now look at it. So you now go back to some of the things that you are trying to produce. Maybe there's need for you to change, there's need for you to improve, and so on. So when you have that, then you now have set of things you are going to make use in order to achieve that particular thing. And like I said, other things like files and processes, you have to be there in order for you to achieve whatever you want to achieve. So at this particular junction, I think we'll call it a day. I will allow you to probably ask questions, and then before we now call it a day. So we will start from this particular place from next week, the same time, 4 to 5 every Monday, from this particular place. So from there, we'll look at the types of system and some other things that I want to achieve by next week. So far so good. I want to thank you for listening and appreciate you all. So let me listen to one or two comments, questions before we round it up for today's lecture. I'm listening to you. Any comment? Question or whatever? Anybody? Our time is fast spent because we have limited time now to round up, and we must round this thing up on time.
Okay, thank you very much, sir, for the lecture. Good afternoon. My name is James Afolabi. Can you hear me, sir? Hello, sir. Can you hear me, sir?
Sorry, the network is not. The network. Yeah, I can hear you now. Yes.
Okay. Good evening, sir. My name is James Afolabi. Thank you very much for the lecture, sir. I just want to
Thank you.
chip in this. That can we have a reminder on our students' mail as it used to be for the class?
The reminder for the lecture.
Yes,
Okay,
sir.
the reminder for the class.
Yes, sir.
You mean the reminder for the class?
Yes, sir. As it used to be on our students' mail.
And of course, this particular one, I sent you mail now. I sent everybody mail. Didn't you see mail?
Yes.
I
We
sent?
received the mail, sir. I received the mail.
I didn't receive the mail.
So I sent mail to everybody. So this mail will be sent every week. In fact, I will be sending it on Sundays evening, reminding you of tomorrow's lecture. So
Thank
that
you so
one is
much, sir.
sacrosanct.
Thank you, sir.
That one
Thank
is
you, sir.
sacrosanct. I will be sending mails to everybody,
Thank you.
reminding you of the lecture
Thank you very much, sir.
every week as we move on.
All right. Thank you very much, sir.
Thank you very much. On this note, we call it a day. I will meet next week by God's grace. I wish you all the best.
Sir.
Take care. Thank you.
Thank you so much, sir. We appreciate it.
Thank you. Thank you.